Let's take a look at an example. We're going to put everything we've learned in this section together. We want to solve this system of equations if we can. So to do that, we are going to first rewrite it in augmented matrix form. That way we could say organize and maybe save a little bit of writing so we don't have to write every variable. So first row corresponds to our first equation. -5 is the coefficient of x. -5 is the coefficient of y in that first equation. -9 is the coefficient of z. And on the other side of the equation, we have the equation equal to -9. So that will be in the augmented part of the matrix. Second row, -4x. There are no y's. -3z, and it's equal to 4. Third equation, third row. -3x, 5y, 3z equals 1. Okay? Now, as it stands, it's real hard to determine anything about this system of equations. But if we want to solve it, the easiest way to solve this is either to get it into row echelon form and then use back substitution, or even better, get it into reduced row echelon form. I personally prefer reduced row echelon form. I think it's easier to work with. Okay? So this is going to be a little bit of work, right? So what I want to do, I'm going to start by getting this in row echelon form, which means I need that stair-step pattern. So I first need a leading entry here. Any non-zero entry here will work. This isn't 0, so I'm ready to go. If this was a 0, if this was a 0 here, then I could start by swapping 2 rows. I need a non-zero entry here. If they were all zeros, that doesn't happen often, but if they were all zeros, then there's nothing to do there, and you just go to the next column. Okay? Okay, so what I want to do, this is going to be my first leading entry, and I'm going to want zeros below it. Okay? When getting into row echelon form, you want to go column by column. So I'm going to go this first column. This is going to be my leading entry, and below it I want zeros. Okay? So to do that, there's lots of ways I can. I could, for example, let's get a 0 here. I could take row 1 and multiply it by -4/5. -4/5 times 5 is positive, times -5 is +4, plus -4 would be 0. So if I take this and add it to row 2, and that's my new row 2, I get a 0 here. That'd be beautiful. Okay? But I'd be dealing with fractions. You want to try to not deal with fractions as much as possible. Okay? Sometimes it's unavoidable. But you want to avoid it as long as you can. So I'm going to start by multiplying row 1 by 4. And row 2 by 5. In fact, let's multiply by -5. Okay. The goal here is to get these to be the same number but opposite sign, so that when I add them together, I get 0. Okay. So in order to get into row echelon form, we're using those elementary row operations. That's our tool set. So I can multiply a row by a non-zero constant. So row 1, my new row 1 is 4 times my old row 1. So I'm going to get -20, -20, -36, -36. Okay. Row 2 becomes, I'm going to multiply row 2 by -5. So -4 times -5 is +20. 0 times -5 is 0. -3 times -5 is 15. And 4 times -5 is -20. And I'm not changing row 3 at this point at all, so I'm going to leave it the same. Okay? Now I'm ready to add row 1 and row 2 together. I'll store the result in row 2. This is another elementary row operation. I could add a multiple of one row to another row. Okay, so in this case, I'm taking 1 times row 1, adding it to row 2. That'll be my new row 2. So notice the only thing that's changing here is row 2. So row 1 stays the same. I think I'll need a little more room here. Row 1 stays the same, negative 20, negative 20, negative 36, negative 36. Row 2, I'm going to add it to row 1 to get my new row 2. So 20 plus negative 20 is 0. 0 plus negative 20 is negative 20. 15 plus negative 36 is negative 21. And negative 20 plus negative 36 is negative 56. Row 3 stays the same for now. Okay, so you could see we're starting to get that row echelon form. Here's my first leading entry. I've got my first 0 below it. Okay, now let's keep going. Let's get the next 0 below it. Okay, to start off, I'm going to go back to this form of my my row 1. So I'm going to divide row 1 by 4. Make the numbers a little smaller. I multiplied it by 4 to make it a little easier to get what I needed here. I'm ready to go back. So 1/4, row 1, that's my new row 1. So negative 5, negative 5, negative 9, negative 9. Row 2 stays the same. Row 3 stays the same. Okay, but now I want a 0 down here. So again, I could multiply row 1 by a fraction to turn this into a 3 to cancel with this one. But I want to avoid fractions if I can, right? There will probably come a time where I will need to work with them, but for now, I can try to avoid them. So specifically, if I get these both to be a 15, I'll be good to go. So I'm going to multiply row 1 by 3. That'll turn this into a 15. And row 3, I will multiply by negative 5. That'll change this into a positive 15. So they'll both be 15s, but this one will be negative, this one will be positive. Okay? Notice I don't really care what's happening at the rest of the row 4 now. I'll worry about that later. I'm just focusing on that first column. Okay? So row 1 becomes negative 15, negative 15, negative 27, negative 27. I'm leaving row 2 the same. Row 3 becomes, I'm going to multiply row 3 by negative 5, so I get positive 15, negative 25, negative 15, negative 5. And now that I have the same number but opposite signs, I'm ready to add these two rows together. Let's add row 1 with row 3. That'll be my new row 3. So I'm leaving row 1 the same. Actually, you know what? While we're here, let's divide row 1 by 3 again. That way we will undo what we did here. We only did this so we could cancel with this guy. Okay. So I get 1/3 times row 1 into row 1, I get -5, -5, -9, -9. Okay, row 2 stays the same. Row 3, be sure when you're doing this, you're using this row 1 and this row 3. Don't use this row 1 with that row 3. Okay, so I'm just going to add them together. Row 1 plus row 3, I get 0, -40, -27, and -15 is -42. -27 and -5 is -32. Okay. So notice I'm getting that row echelon form. I'm working it. I'm getting to where I need it to be. I've got my first leading entry in the first row. I've got zeros below that leading entry. Okay, my first column's done. What I want to do now is I want to worry about the second column. My next leading entry is going to be right here. Okay. And so what I want to do is I want to get zeros below that leading entry. Now, rather than multiplying it by 2 and adding to this, what I notice right off is everything in row 3 is divisible by 2. So I'm going to tidy up a little bit before I go forward. And I should emphasize here, at every step, we're making choices. So I've chosen to divide this row by 2 instead of multiplying this row by 2 and adding it to this one. Either one will work, okay? But you want to try to make choices that are going to make your life easier. In this case, I know dividing by 2 is going to make the numbers smaller. So I want to divide row 3 by 2 or multiply by 1/2. Which means row 1 and row 2 stay the same. And row 3, everything's divided by 2. So I get -20, -21, and what do I get there? -16. Okay, now I'm ready to make this my leading, or to take this leading element, this leading term, and get zeros below it. Okay, so what I'm going to do is I'm going to take -1 times row 2 and add it to row 3, and that will be my new row 3. Because -1 times this plus this will give me 0 right here. So row 1 stays the same. Row 2 stays the same. The only row that changes is row 3. And in row 3, my new row 3 is my old row 3 plus negative row 2. So -0 plus 0 is 0. -20, that's +20, plus -20 is 0. +21 plus -21 is 0. +56 plus -16 is 40. Okay. Okay. So we've reached an important milestone. This matrix is now in row echelon form. And we could tell a lot about what the solution is going to be once we get to row echelon form. Okay? Right away, I can see that we're not going to have any solutions. How do I know? Look at the last equation. This last equation, I get 0 equals 40. That is an impossible equation, which means this system has no solution. So once you get to row echelon form, take a moment and check, do we have a solution or not? If you don't have a solution, you're done. Okay? If you do have a solution, then you have to work to find it. Okay? Either using back substitution or by continuing the row reduction process to get to reduced row echelon form. All right? Now let me summarize the procedure we've just done, because I know it's kind of complicated. Okay? There were a lot of steps. The idea is you go column by column. For each column, you find your leading entry, and you use that leading entry to get zeros below it. Okay? Once you do that, you go to the next column. Okay, so we did that, and where was it? Right there. We had our leading entry, we had zeros below it. Once we're there, we go to the next column. So in the next column, the next leading entry, you go to the next row down. In this case, it's just one column over. Okay? In that column, I have a leading entry. I want zeros below it. I want this to be a 0. And so you use this entry to get zeros below it. And so I did that. I got zeros below it. And once I was there, in this particular case, I was in row echelon form. Got that stair-step pattern. Okay? And so once you're in row echelon form, you can look and you can see, do I have one solution? Do I have no solution? Do I have infinitely many solutions? And that helps you know how to proceed from there. In this case, we have no solution. Once we determine that, we are done. By the way, there's another way to say no solution that's a little more fancy sounding. We could also say the system is inconsistent. Means exactly the same thing. It means that the equations are inconsistent with one another. There's no solution that can consistently solve all the equations at the same time.